Let's look at programming control structures. Every program, whether it's a business program all the way to a video game, has instructions organized in one of three ways: sequence, selection, or loop. With these three types of instructions or control structures, you can write any program. Let's look at the first control structure. This is sequence or sequential instructions. The program will follow instructions one after the other from top to bottom until the program ends. Very few programs would be made entirely of just sequential instructions because the program would run without any pauses or interactions from the user. And I guess that I could have a super simple program that just showed like a splash screen for a few moments and then maybe ran a video or had some information for the user, then that could all be just accomplished with just sequential statements. But usually you'll want more in your program. To make your programs more useful and responsive, they need to accept and react to data or users. And then depending on the data, what the data is, or what the user decides to do, different code can run. And this is going to require our next control structure, which is selection. The selection or the decision control structure creates a point where a decision needs to be made before the code is run. The program could rerun a certain part of the program again, or it could skip code, or you could add different code depending on the outcome of the different decisions. So basically, you're running different instructions depending on the value of certain data. Here's an example of a selection or a decision structure called an if-then statement. The pseudocode reads, if student GPA is greater than 3.5, then place on honor roll. So in the flow chart, the decision would be represented by a diamond shape with the decision or selection to be made in that diamond. The condition to check here was, is the GPA greater than 3.5? If the answer is true, then the student will be placed on the honor roll. If the answer is false, then nothing happened and it will go to the next line in of code, or the program might end if there's no more code past that if statement. Here is another example. It is also an if-then statement, but it has dual alternatives, meaning that whether the condition is true or false, some code will run either way. This is called an if-then-else statement. The pseudocode reads, if student GPA is greater than 3.5, then place on the honor roll. Else, enroll in summer school. Another select structure is the select case, sometimes called switch statement. When you have a lot of possible values to be selected between, you can compare a value to each possible value efficiently with this type of a structure. Only the code that matches the value you're comparing will actually run in the program. In the following pseudocode, the variable grade would have a value in it, like a 95% or an 80 or 69, etc. The pseudocode on this one reads, select case grade. Case grade greater than or equal to 90, place an A on the report card. Case grade 80 to 89, place a B on the report card. Case grade 70 to 79, place a C on the report card. Case grade 60 to 69, place a D on the report card. Case else or default, place a fail on the report card. Note that not all case selects or switch statements let you compare ranges like this easily. Usually it's comparing one value with another one value, not a range of values. But this demonstrates the idea of why you would want this control structure. Otherwise, you'd have to use a really long if. You'd have to say if then, else if, else if, else if, else if, again and again, and it would get really long and inefficient. With this control structure, once the correct case is found, then the rest of the code can be skipped down to the end of the select case. Usually, this is accomplished with a keyword break after the code for that case to let the program know to jump down to below the case statement and go on because a match has been found. We will see all these statements again in more detail later. The third control structure is the loop, also called repetition or iteration. Looping instructions make the computer repeat one or more instructions. In a video game, the loop might keep running all the instructions in the program until the game character dies. Then the loop will end. Loops also save you from having to type the same instructions over and over again. If you want to have a set of data output onto the screen, you can send it through a loop to print it to the screen again and again until all the data has been displayed. Loops can make your code very efficient. A do while or a do until or a while loop will keep running the code until a certain condition is met. Here's an example of running code which gets a number from the user again and again until the user doesn't enter anything in the input box, and at that point the loop would end. The numbers would get added up and divided by how many times it looped to give you an average of all the numbers. We don't know how many times the user will enter, so it's going to run until they are done. And the pseudocode would read do until input is equal to null or nothing. Add 1 to the counter, add input to total, ask for more input. And then you would loop again, and it would keep looping back through the loop. And it would say do until it is equal to null or nothing, add 1 to the counter, add input to the total, ask for more input, again and again. Until, and once the loop is done, meaning the user entered nothing, then you can divide the allowance by the counter and display the average allowance. Another loop is the for next loop. This is different from the while loop because we know how many times the loop should run for a for next loop. So a for next loop will always run a specific number of times. And the pseudocode for this example reads, for class members 1 to 12, display a class member next. For class members, and now you're on the second one, 2, display the class member next. For class members 3, display a class member next. And it will go through, so we know there are 12 people in the class. Even if we weren't sure who would be there that day, we could still find the number or find the count of the class or the length of the class at that time and go through the loop that many times. You will also need to be careful. You will eventually get a false for your conditions, or you might never leave your loops. This is called an infinite loop, and we'll look at loops more closely later as well. So those are the 3 main control structures that will make up every part of your programs: sequential, selection, and looping.